Hi, I'm Shreya. I'm a PhD student at the UC Berkeley RISE Lab working with Aditya Parameswaran, and today I'll be talking about observability for machine learning pipelines. I'll start off by saying that dealing with ML pipelines just flat out sucks. And as a community, we've come up with some pretty cool data management solutions. I'll categorize them into three classes. One around pre-training, which revolves around, okay, what do I need to start training a model? Maybe feature stores, ETL pipelining solutions, etc. Another class is around experiment tracking. What's the best model for a pipeline? And some industry-led solutions such as MLflow, weights biases, et cetera, have garnered a lot of traction in the industry. And finally, I want to motivate a new class around observability. There's a bug in my pipeline. Where is that bug? And I'll define observability as getting end-to-end visibility into a system. Why is observability hard? Well, a lot of things can happen post-deployment, making engineering really, really challenging. Maybe there's some upstream data that's corrupted. Maybe the model developer went on leave and nobody knows how the bespoke ML works. Maybe there are some training assumptions that don't quite hold in practice and more. And another thing that makes these challenges hard is that the tool stack is unnecessarily large and complex, right? As you can see here, for every stage or component in a pipeline, you could have like 10 plus tools that engineers could use to solve the data management challenges, which really begs the question, how do we effectively build a bolt-on observability tool that can kind of work across these different stacks? Why observability? Well, it's kind of impractical to assume that we'll catch every single bug before they happen, but ideally we'd like to minimize downtime for a system when we do find a bug, which means that an ideal observability tool should, one, help engineers identify bugs, and two, help engineers react to the bugs. Something that makes ML observability more challenging than software observability is that we need to support a wider variety of skill sets. So for example, data scientists, engineers, data engineers, product managers, et cetera, need to be able to use the tool. I'll talk a little bit about three big problems in ML observability. One is logging. What's the minimal and correct information that we need to be able to log at runtime to answer a wide variety of quote unquote needle in a haystack queries? Maybe at a first pass that's IO and dependencies, but this quickly becomes very large. Maybe we can log summaries of the inputs and outputs. And another thing we want to be able to log is results of reusable computations, such as data quality tests or data assertions, model assertions, expectations, etc. One could think of these as constraints and triggers for ML pipeline help. I'll also talk about monitoring, which in my opinion is a super large and unsolved problem out there in the ML production literature. The first question is kind of what are the service level objectives for ML? And right now, right, people monitor like this grab bag of percentiles, medians, and KL divergences and whatnot for features. But this can contribute to a lot of alert fatigue and doesn't quite tell you is your actual overall holistic model performance going down. And something that complicates kind of coming up with the real-time SLO, maybe such as precision or recall, is the fact that direct feedback or labels might not immediately be available. So kind of how do we estimate real-time performance at any given point in time? Distribution shift also makes this problem really hard, right? Like the concept could drift, maybe the data actually changes over time, and how do we isolate exactly when a user needs to retrain a model? Finally, the last problem I'll talk about is interfaces for querying when there is a bug in the pipeline. We'd need to support a wide range of query patterns across components in a pipeline and across state or history. And in addition, users need to be able to quickly slice and dice traces for outputs, especially when they don't know the subgroups in the beginning or different subgroups are added to the pipeline over time. Another complication, as I mentioned before, is that the stack is pretty heterogeneous. And ideally, we'd love to be able to build a library of reusable tests, metrics, and pipeline components, kind of like React.js, but for ML pipeline building, so that users can construct, production pipelines off the shelf and get observability for free. So in conclusion, we are kind of working on MLTrace, which is a lightweight bolt-on observability tool to address the challenges outlined earlier. we're thinking a lot about ML pipeline monitoring, and I've linked to some English that I've written over the last couple of months about ML evaluation and monitoring. And finally, we're also investigating current ML-related continuous integration and continuous deployment practices. And if you're interested in chatting about any of this further, please come find me at the conference or reach out to me, first name, last name at berkeley.edu. Thank you.